In this video, we're going to continue our conversation about portfolio theory. Now, you might be able to tell I'm a little bit sunburned because I spent a little bit too much time in the sun this weekend. But that was not going to stop me from shooting this video because I think this video is going to blow your mind. In some of the previous videos, we've talked about things like risk and diversification and negative correlation and why that's important. But in this video, what I'm going to do is I'm going to walk through the math equation for portfolio theory and put all the pieces together and show you how this works. So to get started, I'm going to throw up the equation. And what this is it's looking at a two-asset portfolio. So you have a portfolio with two different assets, asset A and asset B, and based on the percentage each asset takes up, as well as the individual characteristics of those assets, that's going to determine the performance of your overall portfolio. So that's the goal here with this equation, is trying to gain this understanding of your portfolio's performance. So the key concept here is that in portfolio theory, it separates the concepts of risk from return. Now, previously I've always talked about risk and return as related concepts, and they are. Because if you were to go out and buy an individual investment, you would assess the riskiness of that investment and you would build that into the price you'd be willing to pay. So if you were looking at an investment with 10% risk, you would want to discount the future cash flow by 10% and receive that 10% interest. So this idea of risk and return are very related concepts. But what we see when we put investments together in a portfolio, risk and return start to separate from each other. And the reason why this is that because if assets or investments are negatively correlated, the uncertainty between these investments will cancel each other out, because when one investment goes down, another investment will go up. And so the overall portfolio risk will be reduced. And so we're trying to figure that out here. So let's take a look back at the equations. And what you see here is there's two equations here, and the top equation is the equation for your portfolio return, and the bottom equation is the equation for your portfolio variance or your portfolio risk. So looking at the first equation, this is a pretty simple equation to understand. This is just a weighted average of your expected returns of your investments. So it's taking the weighted average, or the weight of the first asset, asset A. So if you have a portfolio that's 60-40 or 50-50 or 70-30, you're going to plug that into this equation. So you take the weight of asset A, the expected return of asset A, plus the weight of asset B times the return of asset B. And that will give you the overall return for the portfolio. That's pretty straightforward, and I think most people understand that. Where things get interesting is when you look at portfolio risk, because we need to factor in this netting out of assets based on negative correlation. And so what you see when you look at the second equation is it starts out in a very similar way. You're taking the weight of the variance of your portfolio for each of these assets, asset A and asset B. But then there's this piece of the equation at the end, and this is what is factoring in the correlations. So the most important part of this is the very last piece of the equation, and this is the correlation coefficient. So the correlation coefficient is going to range between 1 and -1. And so 1 is completely positively correlated, and -1 is completely negatively correlated. And so you're going to look at the expected movement of your assets and determine the correlation coefficient for them. And when you plug it into this equation, what you see is as the correlation coefficient reduces below 0, this whole part of the equation becomes negative. And so what it does is it starts reducing the risk. It reduces your overall portfolio risk. So what happens is, if it's perfectly correlated, if your coefficient is 1, your portfolio risk is going to be pretty close to the weighted average of the variance. So because your assets are moving in the same direction all the time, it's almost as if you have one asset. But the further you get away from a coefficient of 1, is as you get towards 0, your risk starts to reduce. And then when you go below 0, the closer you get to -1, you can reduce your risk almost completely. Because as one asset drops in value, the other asset's going to gain in value. And so overall, the riskiness of your portfolio can be very, very low. So I hope you realize the significance of this equation, because what it's telling you is that you are creating value without having to pay for it. Based on the financial choices you make on putting together your portfolio, you can create value there. I mean, if you just went out and bought an individual investment, you would pay the appropriate price based on the risk. But if you combine it into a portfolio in a smart way, you're actually not holding as much risk as you paid for. So, I hope you realize the significance of this and how powerful it can be. In the next video, I'm going to break down some of the issues that are in portfolio theory and some of the things you should be aware of.